Rolling.
My name is Chris Barty, and this is my material design presentation. So for this presentation, I had to do it on NASA, and basically they were trying to build a rocket ship, and they were looking for the best material to put on the rocket ship to be able to enter the Earth's atmosphere without burning up or heating up too much. So we had to try and find the correct material that had to be flame resistant, it had to be heat retardant, and it had to contain a high melting point. Basically that means it has to resist a bunch of heat, and it has to be able to, it can only melt at high temperatures, and it won't melt while astronauts are in it and burn them up while they're inside. So we were given a bunch of different materials to look at, and we separated them into 4 different groups that consisted of metal, polymers, wooden fiber, and ceramics. So I have them all here. We looked at all the ones in the wood section, and we figured out that they were weak, they burned easily, they weren't elastic. That doesn't really matter for this though, and they had no tensile strength. Metals, they were actually pretty good. They had a high hardness and a high melting point and a high tensile strength, but ceramics, I think, was definitely the best out of all of them because it had the highest amount of hardness and it had the highest amount of tensile strength and the highest melting point out of all of them. Polymers were also pretty weak, so we didn't look at those for any of the materials for rocket ships. So we chose ceramics because it had the highest hardness rating, the highest melting point. It had relatively low elasticity. That's not a big part, but that's just another property. And it has high tensile strength. So out of all the different polymers, or out of all the different ceramics, we chose silicon as our final material because it had the highest melting point out of all the elements there. It had the highest melting point, and it had the highest hardness there. So this is a model of it. I didn't draw this at all, as you can tell, but me and my partner actually drew something exactly like this, and I found it online and thought it would work better. So it's very sturdy, and it has its covalent bonds there to keep it together, and it has a very, very sturdy, just the way it's built with all the bonds put together, it's not going to break apart easily, and it's not going to melt easily. In conclusion, I think silicon is the best material because it has the highest melting point, it has the highest tensile strength, and it has the highest hardness. Thank you.
What'd you get?